Everyone, today we're going to be talking about quite a few things, a lot of definitions, but we're going to start out with linear and exponential functions. For our first definition is, what is a linear function? Well, we talked about this. We talked about it in 8th grade, we talked about it now, but it's a function that has a constant rate of change. When you graph it, it makes a straight line. Okay, what does the function look like? Well, we've seen it before. It's the one that says f of x equals blank x plus blank. Well, in our last chapter, if you remember, in the first blank here was our constant difference, and here was our zeroth term. In the past, it was also our slope and our y-intercept. Okay, so in a linear function, it's going to be your slope and your y-intercept. When you have a sequence, it's your constant difference and your zeroth term. They both have the same meaning, or they're both used the same. So an arithmetic sequence is a type of linear function. So next definition is exponential functions. What is that? Well, it's a graph where the function is growing or decaying exponentially. A lot of you the other day did a problem involving shoveling snow. That's where it really just it started out slow and then it just exploded. The numbers grew really fast, and that's called growing exponentially. What does the equation look like? Well, hopefully you recognize that equation right there. Last unit, with our sequences, it was called your zero term, and then the next one was your constant ratio. Okay, now we're going to leave that alone right now for what the exponential function has. We're going to talk about that in a few days, but that's what the function looks like. It's still going to be the same thing. Okay, next definition, discrete and continuous data. We also discussed this in 8th grade, just a little bit, but not a lot. Discrete data is data that you collect by counting. So it looks like dots on a graph. I'm going to count how many people are in my classroom. I'm going to count how many pairs of shoes I own. Things that you count. Okay, a sample data. The score of the basketball game as it's being played. So let's think about this. The Bears are playing. We're going to have our time here and our score over here on the y side. Well, hey, maybe our score is at 2 or 4 or 8, whatever, and then it jumped up. We didn't score for a while, then we got a dot here. We went up points, and then, man, it jumped in the next quarter, and it went up a whole bunch. Basically, it's talking about what is my score doing? It is increasing, I hope it's increasing and not just staying the same, but you get an entire basket. Nobody gets half a basket. Nobody gets half a point because it went in or went out, or nobody got a half a point because it was really close, so let's give you half. Okay, it's entire points, so you are counting how many points you get. Continuous data is the type of data that you measure. Okay, I measure how tall I am. I measure my age. I measure how long my hair is. I measure a lot of things. Okay, here is one that we can measure. Our height as we grow up. Okay, so these are like the years where you're growing. And over here on the y side is your height. Well, let's talk about my height. Well, I didn't start out at 0. I hope you all realize you didn't start out at 0. So I started about right here. And then my height went up. Okay, it was increasing. I'm not even worried about numbers here, but I increased until, guess what? I got to the 9th grade, and then I stopped growing. I have not grown an inch since 9th grade, but my height has remained constant over all that time. And I imagine when I get really old, I'm going to start shrinking again. So anyway, your height is something that is growing continually over time, and I measure that. I'm not going to skip heights. Even though your mom said, he grew 2 feet overnight, did you? No. You met all those, you crossed over every decimal and you hit every height. You were at one point probably 4.9 inches tall. Okay, so how are we going to use that? First, increasing and decreasing functions. Increasing, it's exactly what you think it would be. It's going up. Okay, what is going up? Well, it's a function where the y values are getting bigger and the x values are getting bigger. So both of them are going up. Where decreasing function, it's exactly what you would think it was. Okay, the y values are actually getting smaller as the x values are getting bigger. Okay, and if you need to pause this video at any time and write some of these definitions down so that you can remember them, that's great. What we're going to do now is we're going to look at graphs and say, what do all of those definitions look like on a graph? Okay, so here we go, our first graph. First, we're going to decide if it's discrete or continuous. So discrete was something that was counted. Another thing I like to remember it as is dots on a graph. Now, there were dots on this graph, but then we connected them by a line. Sorry, I missed a mark there, but because I connected them, this is actually a continuous graph, okay? The dots are all connected. Okay, now we're going to answer the question linear or exponential. So linear says it has a constant rate of change, but it's also making a line. If you look right here, it kind of gives you a good description. Do we have a line? Yes, so this is a linear graph. Okay, the next question, we're using the same graph. And in 8th grade, we used this thing called slope dude to help us. But I'm going to have my slope dude come over here. And I hope that you can see that is slope dude, is he going up the graph or is he going down the graph? Hopefully you're saying, oh, he's going down. So that is decreasing. Now I know that you're saying, oh, well, there's other choices there. Don't worry, we'll find some that are both and neither. We don't use those very much. But for right now, we're just going to leave them alone and talk about the main ones. Okay, now here we go. Here we go again. Discrete, continuous, and not enough information. Okay, discrete means dots. These are not connected. They are just dots. So we have a discrete graph. Okay, same graph. Now we're asking ourselves linear and exponential. If you did the shoveling snow activity, you remember that the numbers started out really close together and then all of a sudden they like exploded and they're going to keep exploding and getting bigger and bigger. Well, that's what an exponential graph looks like. Exponential growth is when things, because you're multiplying the same number over and over and over, it gets bigger and bigger and bigger, or in some cases smaller and smaller and smaller. But this is a typical exponential graph. Okay, now we're going to do slope dude again, and we're going to talk about whether it's increasing or decreasing. Slope dude always travels like you read. He's going from left to right. So slope dude, if you watch, he's going uphill. Uphill on a graph, or uphill with skiing wouldn't be very fun, but there we go. The graph is increasing. The numbers are getting bigger. Okay, next one. It might be a good idea to pause it and see what you get, and then we'll talk about it, but hopefully you've had enough time. Discrete is dots, so this one is a discrete graph. Next one, we're talking about whether it's linear or exponential. Now, imagine it. These dots are not connected, but if I did connect them, does it make a line? Yes, it does. Okay, and I'm going to erase that line because we are not connecting them. I was just connecting them so you could see the line. Okay, next is increasing or decreasing. So let's have slope dude come here. Slope dude is going up the hill or down the hill. Hopefully you answered that it is increasing. He is going uphill. That means that the y values and the x values are increasing. Okay, next graph. Discrete or continuous? You think it through. Hopefully you answered continuous. It's not dots. The dots are connected. There are dots on this graph, okay, but they're all connected. Okay, now linear and exponential. This again is a perfect example of an exponential. We've got numbers that are spread out. They're growing over on that side, or actually they're decreasing, but these are all really close together. An exponential graph tends to kind of look at on the horizontal side like it is almost making a line. It's not really, and we'll talk about that in a few days, but that's what it looks like. Okay, this is an exponential graph. Now, increasing or decreasing. Let's have slope dude help us out. We start on the left-hand side of the graph and we go to the right. Well, hopefully you realize he is going downhill, so that is decreasing. Okay, here's a new one. Go ahead and figure out what you think it should be, and then we'll talk about it. Okay, it would have dots all over this graph, but they are connected. So the fact that they are connected means it is continuous. Next up, linear or exponential. Well, this is where we're finally going to use this other category here. It's not linear or exponential. Exponential has a side that looks kind of like this, but then it's always going to either even out that way, or we erase this. It could, we have this side that looks like this. It could even out this way. It's going to almost look like it has a horizontal line on one side of it. So this one is an example of other. We'll talk about this graph more in high school. Don't worry about it. Okay, now we're going to talk about increasing versus decreasing. So we have slope duties on the left-hand side, and guess what? He goes down, and then he goes up. So he decreased, and then he increased. Hey, there's our both. Okay, here's a new graph. The red part is the graph, so is it discrete or continuous? Hopefully you're saying, oh, that's continuous. It's not dots, it's a line. Next, is it linear or exponential? I hope you're saying, oh, look, it is a line. So it is linear. And the last one, let's talk about slope dude here. It says, is it increasing, decreasing, or neither? So is slope dude going up, down, both? No, he's not doing anything. He's going perfectly flat. There's an example of neither. We won't see a lot of those, but there they are. Okay, now I'm just showing you these just so you understand that we didn't cover every type of graph they are. This is actually a discontinuous graph. You won't even see this on the assignments, but what does it mean? Well, we've got graphs that have pieces all over the place. So they're little sections and they're going in different directions. So just so you know that graphs aren't always discrete or continuous. There's other types of things they can be, but the ones that we're going to focus on in ninth grade are discrete and continuous. Okay, so now let's look at tables. What are we looking for when we're looking at a table? First, discrete versus continuous. Well, that's kind of hard because if I were to graph this, and I'm just going to do a very broad graph. Let's say that's -2, 9, -1, 7, 0, 5, 1, 3, 2, 1. And then here's the thing. You can tell what it looks like, I hope. It looks like it's a line. Kind of my last dot is a little bit over too far, and I can't move it. But it's discrete, but also I don't know if I'm supposed to draw the line. I would have to have a little bit more information because I don't know if with this table, if I'm just supposed to draw the dots or if I'm supposed to connect the dots. It doesn't give me any instructions. It would have to say something up here like connect the dots or something. Draw the line formed by these points. Or maybe it would have to tell me that I only want you to graph these dots. Anyway, I don't have enough information. I'm going to give you a little hint. Unless your table tells you something up here, like you need to connect all the dots or draw a line formed by these points, tables will always be not enough information. Okay, so once again, unless there's instructions that tell you specifically, tables are almost always going to be not enough information. Okay, so we already graphed this one. I hope that, let me just go back to the graph. This one made a what? Oh, you can still tell that it's linear. It did make a line, so we're good on that one. But how else could you tell? Sorry, let's say you didn't want to graph it. Constant rate of change. So 9 to 7, that's going down 2. Okay, that's going down 2. That's going down 2. That's going down 2. What is this one doing? Every time it is going up 1. If we have this constant rate of change, then that means that it is linear. It is adding or subtracting the same thing every time. Okay, is it increasing or decreasing? Well, I know that these numbers are going up. What are these numbers doing? They're going down. So that is telling me that it is decreasing. Okay, let's look at a new one. Okay, we got to figure out how do we get from 2 to 4? Well, this is kind of iffy because I could be adding 2 or I could be timesing by 2, but when I go to this one, I hopefully can decide that I'm not adding 2, it's timesing by 2. Okay, so every time this one is timesing by 2. Well, what are we doing here? We're adding 1. Okay, so once again, sorry I got ahead of myself. I'm answering the next question, but is it going to be dots or is it going to be a line? I don't know. I don't have enough information. There are no instructions up here that tell me to connect the dots or not connect the dots or just draw the dots, nothing. So this one is going to be not enough information. Now I want you to remember the numbers that I got here for the next one because once again I got ahead of myself. Okay, because we were multiplying, it is exponential. Multiplying means that it is an exponential graph. We've times by 2 on every number, on the y value, sorry. Okay, What are these numbers doing? They're going up. What are these numbers doing? They are going up. This graph is increasing. Okay, next one. Why don't you go ahead and take a moment and decide what you think on this. And now we'll do it together. Okay, so this one, once again, it's a table. It's not enough information. It doesn't have anything that tells me connect the dots, not connect the dots. So we're going to go with not enough information. Now we need to decide linear and exponential. Okay, so right here, I am going down 3, then I am going down 1. Hey, here I'm going up 1, here I'm going up 3. These are all going up 1. It's not adding the same thing every time, and it's not timesing the same thing every time. So that means it is going to be other. Okay, now increasing or decreasing. Well, right here, it's going down. Here, it's going up. Here, it's going up. So guess what? This one is both. Okay, now we're going to look at equations, and we're going to combine that with sequences, because the formulas that we use on any equation, linear equation, exponential equation, are also our sequence formulas. So we're looking at this. We've got 2x minus 3. The first thing I do when I see a graph is I kind of want to graph it. Okay, so here we go. I'm going to go down 3 because I know that this one looks, hopefully you're recognizing that this is linear. Okay, and then we go up 2 over 1, up 2 over 1, up 2 over 1, and there we have it. So I can keep going my graph. The problem is this is kind of like a table. Do I connect the dots or do I not connect the dots? Does it give me any directions right here with this, or does it just give me the formula? Because guess what? This could be a sequence. What would it look like as a sequence? It would start with first term, second term, third term. It really didn't say, hey, this is an arithmetic sequence, or I need you to draw the line. So this one is going to be an example of not enough information. Okay, remember what that graph looks like. Okay, it is going up, and what kind of a thing does it make? I hope that you're noticing that it would make a line for our next question. So the question is it linear, exponential, or neither? I'm also going to show you how you can use a graphing tool. You can use your graphing calculator, or you can use this thing called Desmos. So we have 2x minus 3. I'm going to bring this over, and here we go. Where did it go? Right here. Sorry, I can make this work. Okay, so I'm going to type this in here. F of x equals 2x minus 3. And it has that line there. Hopefully you can see that that is, whoops, I went to the wrong one. It is a line, but is it increasing or decreasing? Imagine slope, dude, and I hope you're saying right now that this would be increasing. It is going uphill. Okay, I'm going to go ahead and leave this up because now we're going to have this next line here. Okay, let's talk first about discrete, continuous, or not enough information. When you have a graph, unless it tells you that it is a sequence or it tells you that it is a line, we're going to go with not enough information because I don't know if I'm supposed to connect the dots or not. Let's go ahead and type it in though. So when you do type it in, it is going to show you a line. It will show you that it is a line. Okay, but once again, we don't know if it's a sequence or not, and that's why we're always going with not enough information. So let's go to the next question. Linear, exponential, or other. Look at this. It looks like it's kind of got the horizontal line going here. We're going to talk about this in a few days. And then it's going almost straight up, but it's not straight up. It's just increasing there. So this one is an example of exponential. Okay, let's go ahead, and while we have our graph up, increasing, decreasing, or neither. So we start over here on the left-hand side of the graph, and we're going uphill. So this is an example of increasing. Hey, guess what? You have a calculator or you have a computer. You're using one right now. If you type in Desmos, you can graph in it, and you don't have to guess on these. You don't have to look at an equation and say, I'm not really sure what I should do. The graphs are there. Okay, use the tools that you have to figure these out. Okay, here's the next one. Let's go ahead and graph it. X squared. Hey, we've seen this before. There's my graph. Okay, first, discrete, continuous, or not enough information. Once again, it does look continuous on here, but it didn't tell me if I should connect the dots or not. we're going to go with not enough information. Graphs are usually not enough information unless it tells you more information. Okay, equations, sorry, not graphs. Now it's linear, exponential, or neither. Well, this one doesn't have that side that flattens out. It's definitely not a line, so we're going to go with other. Next up, increasing or decreasing. Well, here it is going down, and here it is going up. And so that is going to be both. It is increasing and decreasing. Okay, now I'm going to get rid of this and make it big again. Okay, we don't need our calculator anymore because hopefully you recognize that this is a recursive function. Remember, this is telling me it's a sequence. I know that my first term is 2, and then it tells me I'm adding 2. So I've got 4, and then 6, and then 8, and then 10. Hey, that is a sequence. I do know what that is. Those are just individual numbers. That is discrete. Okay, looking at the same thing, is it linear or is it exponential? Well, it went 2, 4, 6, 8. It was adding the same thing every time. That means it is linear. It has that constant rate of change. Let me pause this for a minute. Nope, I think we can keep going even though the bell rang. Okay, so next up, we're going to look at this. Is it increasing or decreasing? Well, that right there is telling us that it is increasing. Now I'm just going to give you a sequence. It is very similar to the one that I just gave you. Is it discrete or continuous? Sequences. It's individual numbers. If we graphed them, I know they would be individual dots, so that is discrete. Okay, is it linear or exponential? Well, it is adding 2 every time, so that is going to be linear. It is adding the same number every time. And the last one is increasing or decreasing. Well, it was going up 2 every time, so that is increasing. Okay, let's get to our stories. This is the last type of thing that you have to decide if they're discrete or continuous or not enough information. So first, the number of hairs on your head. Remember, with a story at the beginning, it told you that it was data that was counted or data that's measured. So if you wanted to know how many hairs are on your head, are you going to count that? Or are you going to take a ruler and measure it? Well, hopefully you're saying you're going to count it. Now, I don't know why anybody would want to count it, but counting the numbers of hairs on your head is what you would do. Now, linear, exponential, or other. Now, this isn't a real good example, but I still like to use it because it's something that I think most kids know that they would count and not measure. But the ones that we give you on the assignments, you will be able to tell the difference pretty easily. Now, I think that usually it's going to be a linear thing, that you're going to increase by the same number of hairs per year or something, but I don't know that. Okay, so we're going to go with other on this. Once again, I think it would be linear, but I don't know. Okay, next up, the number of hairs on your head. Just a minute, somebody's trying to get in my room.
You busy?
Yeah, I'm making a video.
Okay.
Okay, sorry.
Oh, it doesn't look like it's done anyway.
Okay.
Okay, see ya.
Okay. So, number of hairs on your head. Do you think that's going up or is that going down? So I'm going to give you 2 examples to kind of help you out with that. Here is Mrs. Shaw. Now, Mrs. Shaw has a lot of hair, and she also has a little baby in her arm. And you think about it, do you think that they're getting more hair or they're getting less hair? Well, I'm going to go, especially if you look at that cute little baby there, that their hair is going up. Okay, they're increasing their hair. But then we have another example over here. We've got Mr. Runyon and his dog, Poika. But Mr. Runyon's hair is definitely going down. Okay, so this is one where I wouldn't know if you were going up or down. It depends on the person. So we're just going to say neither. We don't really know on this one. And once again, I won't give you anything on the assignment, but, kind of fun to look at. Okay, next up, the length of hair throughout the week. Okay, we're talking about how long your hair is throughout the week. So are you going to measure it or are you going to count how long it is? Well, you're going to measure it. Girls are probably better at this. They measure it. Boys, think about it. You have to get your hair cut pretty often because your hair is growing. Okay? The length of your hair throughout the week, is it linear or exponential? I think hair grows at a pretty constant rate. Okay, so I'm going to go that it is linear. I think it just is continuing growing at the same thing. I know that people would argue with me, what if I was taking a supplement, that kind of thing, but for the most part, I think the normal person, it is pretty linear. And the last one, is the length increasing or decreasing? I think for everyone, the length is increasing. Even Mr. Runyon, who has, not very much hair on his head, it is still growing. He still has to get a haircut on the hairs that are there. Okay, last one. Mrs. Udy put leftovers in her fridge that her kids refuse to eat. So we're going to talk about the growth of the mold. Okay, so think about it. Mold starts somewhere, and then what does mold do? It just keeps going, but it's individual points, okay? It is something that you would count. I don't know why anybody would count it, but you're going to count how much mold there is. And you've seen it. You've seen little spores of mold. You count those little spores of mold. Okay, then we're going to talk about, is it linear or exponential? This is actually exponential. I mean, you've seen mold. One day it's got a little bit, the next day it's got a lot of it. It just keeps growing and growing and growing. It gets bigger and faster. And the last one, is it increasing or decreasing? Hopefully this one's a no-brainer that it is increasing. So hopefully that helps you decide whether things are increasing, decreasing, discrete or continuous, or linear or exponential. And we will figure out where my blue thing is.